While the world is distracted by the ceremonial loops of NASA's Artemis II around the moon this week, a far more radical engineering miracle is reportedly taking shape in the high-pressure labs of Shanghai. For decades, the surface of Venus has been considered a cosmic no-go zone, a 470-degree acid hell where lead melts and atmospheric pressure crushes titanium like a soda can. But in late March 2026, leaked schematics and thermal testing data from the China National Space Administration, CNSA, suggest they aren't just looking at the moon's craters anymore. They are iterating on the advanced white and red lunar suit they debuted recently, pushing its composite materials to the absolute thermal limit. Could Beijing be developing a specialized exoskeleton of hell designed to survive the most lethal environment in our solar system? Today, we're stripping back the propaganda to see if China has actually cracked the code for a Venusian surface mission. In this deep dive, we're going to uncover exactly how a human or a highly advanced humanoid robot could step onto the burning sands of Venus without vaporizing in seconds. We'll analyze the secret liquid metal cooling patents that appeared in Chinese journals this month and discuss why NASA's aging technology simply can't keep up with this new era of extreme materials. Is this a legitimate breakthrough in carbon ceramic armor, or is China using Venusian hype to hide a much darker military application for their deep space gear? Stay tuned until the end, because we're revealing the three-stage blueprint that could see a red flag planted in a place where even machines go to die. If you're ready to see the future of forbidden space travel, hit that like button right now and subscribe to Exoplanet X. We're tracking the missions they don't want you to know about. To understand the sheer audacity of a Venusian suit, you first have to understand the nightmare that is the surface of Venus. With a surface pressure of 92 atmospheres, equivalent to being 3,000 feet underwater, and temperatures reaching a constant 470 degrees Celsius, any standard spacesuit would implode and incinerate in milliseconds. However, in late March 2026, China's recent unveiling of their ultralight lunar EVA suit showed the world something critical, a masterclass in carbon fiber composite layering. While NASA focuses on traditional, bulky, pressurized fabrics, the CNSA is experimenting with rigid, phase-change material skins. These materials can absorb massive amounts of heat before the internal temperature even begins to rise. It's not a suit yet, but it's the most advanced thermal shield ever designed for a human-shaped frame. The real secret behind the possibility of a Venusian mission lies in what Chinese journals are calling active refrigeration cycles. While NASA's current suits use simple water cooling loops that would boil instantly on Venus, leaked reports from the Harbin Institute of Technology suggest the shift toward liquid gallium cooling systems. Gallium remains liquid at high temperatures and has an incredible capacity for heat transfer. By integrating a closed-loop micro-pump system into the rigid exoskeleton of the suit, China could, in theory, create a portable refrigerator capable of maintaining a livable 20 degrees Celsius inside, even while the exterior shell is glowing red from the Venusian heat. This isn't science fiction anymore. It's an evolution of the thermal management systems China's already using for its high-speed hypersonic glide vehicles in 2026. But there is a catch that even the most optimistic engineers in Beijing have to face: the sulfuric acid clouds. The atmosphere of Venus doesn't just crush and burn, it dissolves. For a suit to survive even an hour on the surface, it would need a coating of polytetrafluoroethylene ceramic hybrids, a substance so non-reactive that even the most corrosive acids slide off like water on a rain jacket. While we haven't seen a full Venus suit yet, the materials war of March 2026 is showing us that China is testing these exact coatings on their new deep space probes. If they can protect a robotic arm from the acid rain of the upper Venusian atmosphere, the leap to a manned exoskeleton is much closer than the West is willing to admit. The question remains, why would anyone risk a multi-billion-dollar suit and a human life in a place as lethal as Venus? The answer, as of March 2026, is no longer just about scientific curiosity, it's about resource supremacy. While the world is obsessed with lunar helium-3, Venus holds a different kind of treasure, an atmosphere rich in rare isotopes and chemicals that are nearly impossible to synthesize on Earth. Some analysts suggest that China's interest in Venusian survival is a cover for a long-term plan to deploy automated, floating refineries in the upper clouds. By mastering the materials needed for a surface-rated suit, Beijing is developing the same tech required to build durable, acid-resistant infrastructure that can harvest the energy and minerals of the morning star, effectively bypassing the logistical nightmare of mining on the moon. But the real shocker of March 2026 is the experience gap. While NASA is currently stalling its Venus missions due to massive budget cuts and the immense pressure of the Artemis mission, the China National Space Administration is moving with a fail-fast mentality. By testing their new suit's ceramic metal hybrids in high-pressure chambers that simulate the Venusian surface, they are gathering data that the West hasn't updated since the Soviet Venera missions of the 80s. If China successfully deploys even a robotic avatar in a humanoid Venus suit before 2030, they won't just win a trophy, they will claim the high ground of the inner solar system. The forbidden suit isn't just about walking on hell, it's about proving that China can go where America is simply too afraid or too broke to follow. The true purpose of China's forbidden suit may not be a human walking on Venus today, but the terrifyingly advanced material science it generates for the military and deep space hardware of tomorrow. If a material can withstand the 92 atmospheres of Venusian pressure and the corrosive acid rain of its clouds, it can survive anything. By testing these exoskeletons of hell in March 2026, China is effectively building a library of supermaterials that NASA simply doesn't possess. This tech will eventually trickle down to their lunar bases and Martian rovers, making Chinese hardware virtually indestructible compared to the fragile, solar-dependent probes of the West. The Venusian suit is the ultimate stress test for a nation that intends to own the harshest environments in the galaxy. As we move deeper into 2026, the gap is widening. While NASA's budget is tied up in the bureaucratic delays of the Artemis program, China's private-public partnerships are moving with a ruthless, singular focus. The Red Dragon understands that to lead the future, you must conquer the places where others fear to tread. If they can plant a flag, even via a robotic avatar in a human-rated suit on the surface of Venus, the psychological blow to American space prestige will be permanent. It won't just be a scientific milestone, it will be a declaration that the era of Western orbital dominance has officially ended, replaced by a power that can literally walk through fire. We are witnessing a pivot point in human history. The forbidden suit is more than just fabric and cooling loops. It is a symbol of a new superpower that refuses to accept the impossible. But what do you think? Is China's Venusian ambition a brilliant strategic move, or is it a massive waste of resources in a race that can't be won? I want to hear your theories in the comments. Does NASA have a secret countermove, or is it already too late? If you enjoyed this deep dive into the most dangerous mission of 2026, make sure to smash that like button and subscribe to Exoplanet X for more unfiltered space analysis. We are tracking the moves that change the map of the solar system, and you don't want to miss what's coming next. I'll see you in the next one.